All right, well, let me go ahead and get started here to kick off the SIG meeting. Couple of just updates and housekeeping things that that we've been doing. Hector, who normally organizes the call, is kind of in between jobs and is handling some things related to that and just personal logistics. And so so he asked me to pass along a message. We have, I think, still some folks who are normally with us who aren't here, but if anyone is going to the Bergen conference, Hector and I won't be able to go, but he and I are both willing to help organize whatever presentation and activity that the SIG does at the Bergen meeting, because we will have a slot for a SIG meeting at the conference. So if you are attending, or maybe you know someone who kind of who will be going that has been a part of the group, then just let us know, because we can help you, or we're willing to help kind of organize that for the meeting. And then just kind of another plug related to that is that we've had a pretty good group for the Ag SIG now going for a couple of years, and we had kind of put this this plug out there that maybe it would be time to do something as a SIG. And so it's obviously too late to do it this year, but we do have a couple years of momentum. So I kind of want to just plant a seed and suggest that or challenge those of us who come to the SIG or attend the SIG regularly, that we try to come up with something that we do for the Chicago conference in 2021 that's outside of the normal SIG meeting time that we get at the conference. So I'm not sure what it is, but I'm willing to and interested in having some upcoming Ag SIG meetings about what that may look like, whether we do a presentation or a poster or a paper together, whatever that may look like. I think with the ordinary attendees and the fact that we have 2 years now of momentum, I think it'd be a worthwhile next step to pursue. So with that kind of house cleaning out of the way, I will try to jump over to the presentation. Now, at the moment, everyone has muted, which is fine, but if a couple folks wouldn't mind turning on their camera, just so that I get that visual feedback in case something goes awry, I get that verbal cue that thanks, Christine, that things are progressing as they should. So let's go here, and then I need share. All right, so Christine, can you see that title slide? Does that work right? Okay, perfect. So, so what I wanted to share with the group today was an effort that I've been a part of for a few years now that we've called Curriculum Development for Wicked Problem Solving. and I'll share with you kind of the process.
Ben, excuse me, this is Saeed. I hear a lot of background noise. I think it is from Alberto. So um, thank you, Alberto.
Yep. So I'll share with you the details of what we've been doing the last couple of years on this effort, and the point of this picture here that that just kind of looks like a mess of a field. It's because it is. It's Palmer amaranth in a soybean field. So pretty important issue in terms of crop production and resource management. So all of us are aware that today's problems are not getting any simpler to solve, and because of the systems that we study that are long-term and complex, we know that the often misleading feedback that we get confound and confuse management efforts. So with this effort that we've been doing for the past couple of years is to try to embed systems thinking and system dynamics into graduate training that is primarily single discipline or siloed focused. You know, it's great if we can get systems training from the 3 or 4 institutions that have systems programs, but for, you know, the other 99% of us out here that just don't have the faculty capacity to do that, how do we do that? So this has been one of our efforts to try to do that. And so we've done that through this integration process to try to develop some case studies and teaching resources for folks that are in our situations where we have some systems training and system interest, and are building that in our students and in our programs, but maybe don't have easily accessible or translatable material for what we're trying to do. So what we've done is we put together a what we call a systems thinking fellowship for grad students, and I'll get into our institutions and where these students are coming from in just a moment. But we're currently right in the middle of this fellowship. So we started with a systems thinking lectureship here in Kingsville, Texas, where I'm located. We did that back to kick off our fellowship, and that kind of merged or meshed all of our groups together, and I'll tell you more about that experience. After that 4-day lectureship, we did and are continuing to do a series of webinars on systems thinking and dynamic modeling. And again, I'll share with you kind of these things. So those are some of the things we've done. And then upcoming that we're working up towards at the moment is a capstone event in managing complex systems, and that's going to take place in Fort Collins, Colorado, where one of our cohorts is located. So the grant effort, part of the grant that's funding this fellowship, we needed to document what would be some student learner outcomes from this process that would be worthwhile for the funder to get behind. And so again, based on that idea of systems thinking and dynamic modeling and reasoning, this is kind of some things that we've tried to embed into the cohort of the fellowship process along the way. So first of all, it's interdisciplinary for sure, and I probably won't have time to tell you about all of the cohort members, but just as an example, all of our cohorts are like this. So in the cohort that we have at A&M Kingsville, we have an environmental science person, an ag business person, we have an ag education person, and an agronomy person, and those are the students in the fellowship. And for the other institutions, it's like that as well. We've got animal science, ag engineering, environmental science, so on and so forth. And with the projects, I'm gonna share a little bit about the projects that we're all working on. Because of that diversity coming to the table, the projects are very much interdisciplinary as well. They've got to be problem-based because, you know, as systems thinkers, we've got to deal with some pretty important problems that mean something in the real world to people that are out there managing. So that's another element of the problems. It's got to be team-oriented, and so as I share with you in just a moment how this process is unfolded, hopefully it will be evident how oriented it is to the team environment and building the cohesion amongst the cohorts. An important one for us is experiential learning, because we don't have typically the capacity in our programs to actually build and flesh out an entire kind of systems sequence of courses and programming into our degree plans. And so this is really based on experiential learning. So when I talk about, we did a lectureship, we did these webinars, we're doing these hands-on presentations by the students, it's to immerse them in this one-year-long process of applying the systems approach. Along the way, as they do those presentations and we work up to the capstone event and have some presentation materials ready, is to develop those communication skills. And again, because we're a diverse group of cohorts, we've got to be able to communicate these issues to a diverse set of audiences. Obviously, if it's going to be systems oriented, along the way, we should be developing critical thinking skills to get to the root causes of the problem. And then lastly, another thing that kind of sold it for the funders is career preparation, because by organizing this fellowship, we're giving students yet another experience in the real world problem solving that is above and beyond their coursework and their thesis or master's project, whatever they're working on. So that's kind of the framework for what we've tried to build out in our fellowship program. So here's where the cohorts are located. I'm at Texas A&M Kingsville, and so what I'll share with you are the institutions here and our focusing questions that are the projects, the focusing questions of the projects that the groups have been working on for their fellowship. So here at Kingsville, our focusing question, and related to the title image that I showed you a few minutes ago, despite modern agricultural advancements, why does herbicide resistance continue to outpace innovation efforts? And I'll share with you quite a bit more about our project, about the herbicide resistance issue here in just a moment. At University of Nebraska, Kearney, my collaborator, that's where you saw the link, the UNK Zoom link from, is at University of Nebraska, Kearney. And their focusing question for their project has been, why do challenges to land purchasing or acquisition for conservation by NGOs persist? In that particular region, land conservation is critically important because they don't have the rainfall to support large-scale cultivation. Only in certain areas is cultivation really that sustainable. And so, so it's a very important issue that they're looking at there. Next, at the University of Minnesota, the cohort there is looking at another important issue. Why are row crop farmers in the Midwest slow to adopt cover crops? And just to share with you a little bit about why that issue is important, if you're not familiar with conservation ag adoption, is that USDA kind of tracks the adoption of conservation practices by farmers in the agricultural census. And although a lot of practices have increased in their adoption, over time, something like conservation tillage is up to somewhere around 25 to 30% adoption across U.S. farmers. And so those are all positive signs, but a really kind of head scratcher is from census to census, the past census year, the cover crop adoption has actually gone down. And so it's really perplexed a lot of people in the conservation ag on why that would be. And then lastly, at Colorado State University, where we're having our capstone event, there it's not a student cohort, it's a faculty cohort that is there. And so those faculty are doing sort of their own continuing education in systems thinking and dynamics to build their own capacity where they do have the faculty capacity to maybe build out and flesh out their own program. So that's what that cohort is working on. I'll come back to those in just a minute, but just to kind of give you a flavor or sense of how the fellowship has transpired over the past year. So as I said before, we started with the systems thinking lectureship here in Kingsville, and we spent the first day playing the beer game and doing the beer game simulation and debrief, which takes most of our first day, but it was much deeper than that as well, because we did a four-day experience. And so here are some of the pictures of our cohort members throughout the process that when I say experiential and immersive, this is what I mean. 4 days of hands-on systems thinking applications, getting into the problems, working as a team, and quite exhausted after 4 days of that, but we've left that experience better for it, and it really has propelled our cohorts over this past year with the equipment, the thinking that they need to continue to dive deeper into their problems. After that experience at our home institutions, the cohorts continued to work. And so I'll just give you a flavor for this without getting into more video, but I just took some screenshots of what this looked like. So we came back together online through a series of webinars and systems thinking where we updated the other cohorts on our progress. We asked questions of clarification and prodding from the other groups to try to draw out maybe some illuminating or counterintuitive things about each other's projects. And over a series of those webinars and presentations, it really drew out a lot of things that helped the cohort members think about some things they had not thought of before. So those are just some captures of those, and you can see some of the cohort members there that were presenting. After that, I've kind of taken the lead on doing some training and system dynamics modeling. And so again, in the webinar format, we come together online, provide them the tools. Here you can see that we just use kind of a very elementary model. The content for that is really not important, but a small scale model that the cohort members could get their hands around and understand pretty quickly. And so we've done that, and that's kind of propelled us into the modeling stage now that we're into getting into the spring semester to lead up to that capstone event in Fort Collins. And here, this is what I share with my cohort and all the cohorts, is good modeling work is the development and expression of your creativity. And I think that as for all of us that do a lot of modeling and have some exposure and experience to these sorts of projects, it really is about creativity, because these problems, you know, they don't really have solutions that are off the shelf. As I tell my students in class about 21st century agricultural and natural resource problems and why they're so important, because if the answers were in the book, then they wouldn't be a problem. I mean, those things would already be taken care of. And so, so I think the systems approach is the one of the best, if not the best, beds for developing that creativity because of the integration, putting the both hard and soft variables and data together, so on and so forth. And so, so I think that will come out in the end, and hopefully that will come out as I share with you some of the thinking done by the cohorts. I may skip over this a little bit faster than I would like, but I want to get to the herbicide resistance problem that the cohort here in Kingsville has been working on. But I didn't want to leave, out of respect for the other groups and the work that they've done, without at least giving a flavor for their thinking and their development for their particular projects. So the Minnesota group, their focusing question has been, why are row crop farmers in the Midwest slow to adopt cover crops? And so without getting into the nuts and bolts of theirs, I just thought I would share as quickly as I can their dynamic hypothesis about what that would be. And so what they've come up with is this kind of dynamic hypothesis that helps potentially explain why that cover crop adoption is stagnant or even declining. So a relatively shorter growing season in the upper Midwest intensifies the time and energy and therefore costs associated with raising crops to meet their production potential. Although some cost share programs exist and evidence shows long-term soil health gains from diversified agricultural systems via cover crop integration, producers remain reluctant to adopt due to the reliance on short-term, year-to-year results of production. Because annual production is partly driven by weather variability, which creates uncertainty in growing season conditions conducive to crop growth, producers' reluctance to adopt cover crops is reinforced due to the necessity of maximizing conditions and resource utilization that directly influence productivity. So I really like that because you can see kind of the short-term pressure that's being felt and how sort of the short-term decisions erode the longer-term potential gains in the system that could be gained through cover crop adoption. Our University of Nebraska at Kearney cohort, their focusing question has been, why do challenges to land purchasing or acquisition for conservation by NGOs persist? And as I said before, this is a pretty important area for that part of the world because cropping is really not sustainable in a lot of areas, but those decisions have, you know, decadal to century consequences. And so NGOs have really prioritized the Northern Great Plains as an area for conservation. So the feedback dynamic hypothesis view that they've kind of come up with so far, which I also really like, is along these lines. So as the number of threatened and endangered species continue to increase, the need to preserve and conserve habitat for those species is also increasing. Undisturbed or minimally disturbed lands are being repurposed for agriculture or residential commercial development. The availability of ag properties in particular may increase as producers age and profitability decreases. Conservation-oriented NGOs may purchase or acquire land via donations in order to increase habitat for native species of concern. Still, challenges persist in land acquisitions as the willingness to sell or donate land to NGOs is complicated by trust, land ethics, and other concerns, thus limiting the ability of NGOs to provide for conservation of threatened and endangered species. So hopefully that gives you a sense of some of the issues that we're dealing with in that land conservation issue, with the age of producers, the profitability, the expansion or the demand for cropland, as well as these sort of soft things like trust between producers and NGOs and the land ethic for what they view as the highest and best use of that land moving into the future. So no shortage of complex factors going on there as well. Hopefully that gives you a sense. I'll dig deeper into our herbicide resistance project. So again, our question has been, despite modern agricultural advancements, why does herbicide resistance continue to outpace innovation efforts? So let me dig deeper here for a couple of minutes into our project. Following the systems approach that we started back in August with our systems thinking lectureship has really been centered around the iceberg diagram concept. I don't think I have to review that for anyone here, but that's kind of the process that we followed. So we know that there's been some major events of explosive weed growth and prevalence due to some resistance. And so digging below the surface or looking below the surface of the iceberg, what are those trends and patterns and structures? So here's the global cases of unique weed resistance over time. This comes from weedscience.org that catalogs all of the data related to herbicide resistance by weeds. And you can see there's really no resistance until about the mid-70s, and it's just continued to grow each year after that, upwards of between 500 and 600 now cases of unique herbicide resistance. Here's some USDA data about pesticide use from not exactly the same time, but kind of a cross section in there from 1960 to 2008, and you can see how pesticide use has grown, but where the growth has been has less in insecticides, fungicides, or other pesticides. It's really been an herbicide application and growth that dominates the use of chemical in the ag sector. And then an important one that's a little bit harder to graph in a graph, temporal graph over time, but I think this is illustrative. So here's a 1968 data about the types of herbicide being used at that particular point in time. And what I want you to notice about this graph is kind of the proportions of different chemicals. And there you can see atrazine, 2,4-D, so on and so forth of the chemicals. Now, when we look at 2008, the ratios really aren't that different, but all the chemicals are. So there's been a tremendous shift over time, again, because of the number of chemicals and whatnot. It's a little harder to show, but there's really been a shift in the type of chemistry that's been applied in these herbicides. Here's one that does try to attempt to show that shift from, again, a little bit shorter time period in the longer time scale. So this is from 1990 to 2010, and you can see the volume being applied. This is not to all the crops, just a subsection or sample of crops. And you can see that the green line that's very high to start off eventually is no longer there. That's 2,4-D. You can see one of them, the yellow one, that kind of starts small and grows and then starts to level off and maybe decline a little bit. That's the chloron. I can't even say it, but the second one there listed for potatoes. And then, of course, the really illustrative one is in red, which in 1990 is hardly present, but by 2010 dominates the use, and that's the glyphosate use. So there's been some shifting in the chemistries is what all I'm trying to communicate there. But because of that shifted chemistry, partly in response to what resistance has been showing up, here's the number of weed populations with multiple herbicide resistance capabilities. So you can see there too. So of that 500 or so species that have resistance, about 10% of them have at least resistance to 2 different herbicide varieties. And then a little bit smaller for 3, 4, 5, or greater than 5. But when you add those up, that's a large, 10% that have multiple herbicide resistance. So that is underlying that herbicide resistance growth that I tried to show in the first trend over time. And then lastly, in terms of what does all that mean for the crop production system, this is the expenditures from 1960 to the present for pesticide use, which is again dominated by the herbicide use. And although it's growing, you can see kind of since the mid-70s, it does grow. Obviously, there's some fluctuation in there, but it really doesn't take off quite like the seed. The seed has become really one of the major variable costs to the production system. The pesticide is still there, but what's become even more important is what the seed has done to the production cost, and I'll come back to that, why that's important in just a second. So those are some trends and patterns over time. So what are some general structural things that the group has pointed out? Well, similar to some of the other problems, there are short-term pressures that lead producers to rely on chemical herbicides to maintain their production potential and quality. And the development of resistant crop varieties that allow for that rapid application of glyphosate incentivizes dual adoption of the seed and chemical application. So like that seed cost going up, the reason for that cost going up so greatly is because of the innovation in crop genetics that allow those crops to be herbicide resistant. So when we see the seed costs going up, we also see the glyphosate use going up because we're now embedding the genetics to be resistant to that. And then finally, the switching for multiple resistance. As weeds do develop resistance, producers have been switching, or they alternate between chemical varieties until weed populations rebound. There's different modes of action or sites of action that the chemistries of these herbicides will use. And so if there's pre-emergent versus post-emergent, there's things that are metabolic, there's certain ones that are reproductive, so on and so forth. So they're switching between those chemistries to try to handle the problem, but as we'll see, only sort of prolongs the problem. In terms of policy, the production incentives really only support a few annual crops. And so because of that, the innovation and the seed genetic and production genetics has really only focused on those crops rather than other crops that might be grown or perennial systems, so on and so forth. And then specialization in chemicals requires training and monitoring, i.e. additional monitoring and workload for the farmers that then escalates the production and profit pressure they already feel. And then deeper into mental models, this is kind of our synopsis when you put these voices together that we've been hearing. Try to distill that down into the description of a mental model, in that it's the primary and most effective tool available to me, i.e. chemical herbicide treatment is the most effective tool that I have available. There are less disruptive methods available, but I'd have to change my entire production system and at the risk of reducing my yields, profits, or both. And so that's a pretty steep hurdle to get over in terms of changing the production system when we are so capital intensive and locked into the production system that we have. So from all of that data, what our cohort did was develop this feedback structure. I'll show you the larger CLD, the archetype, and then our stock flow diagram from that, again, as quickly as I can, because I'm trying to watch the time. So the first variable we have here is the weed pressure felt by farmers, and as that pressure is felt, then there's certain herbicide applications that are applied to try to handle it. And in the short term, it probably does handle it, but as inevitably what happens is as the selection pressure from the herbicide does in fact do its job in treating the weeds that are there, it's never perfect because there's some weeds that do have the genetic expression that will be resistant, albeit a very small fraction of the population. But as that population remains in the seed bank, there's a delay which will come back and perpetuate the pressure felt by the farmer. So in other words, that small fraction of the population that is resistant to that does reproduce, it ends up in the seed bank, and it's only a few years later when conditions are right again for that population now to become the majority of the population that becomes resistant, and that then escalates the weed pressure felt by farmers. So that's really the underlying biologic reinforcing process that's driving the herbicide resistance issue. I'm going to attach some loops to this, the first being some economic ones. So as that weed pressure is felt, there are implications for crop production because the quality and yield is reduced. And so that reduces the revenue and therefore the profit. And as the producers feel the pinch in profitability, there's pressure on them to change, or the stress level is escalated. And so there's push on their productivity goals. We've got to get our productivity and quality back to our profitable levels if we're going to be sustainable. And so through that, they're willing to adopt and plant advanced hybrid seed varieties that are more efficient from the herbicide side, maybe their herbicide resistance, but also from the resource utilization side, because irrigation applications or fertilizer applications become that much more efficient. So as that adoption takes place, we're able to do more crop-specific herbicide use, so more advanced type of chemistry specific to that crop, and would help alleviate the weed pressure felt by farmers. So that's the first balancing process to offset that, is that adoption of the advanced varieties. Unfortunately, though, maybe you can see where this is going. As that adoption and crop-specific use goes up, that comes at a cost. The cost of the treatment then goes up the more advanced the application becomes. And so if the cost of treatment goes up, that's also going to offset what gains we have in farm profitability. So there's kind of a reinforcing economic pressure there as more investment in the innovation and hybrid seed and chemicals go up. That reinforces the economic pressure for the threshold that the producer has to reach. From each of those, as the percent population that's remaining resistant to the herbicide remains, and again, that's a delayed thing because the portion that is resistant we don't see. It's in the seed bank. It only expresses itself years later when the conditions are right. That incentivizes an increased frequency of treatment, along with the crop-specific herbicide use, puts pressure on the seed companies that are doing this innovation to make more effective resistant crops. And so as that takes place, there's seed company research and innovation that eventually gets pushed through the crop input sector, that eventually makes its way to management and research extension efforts. And as those things take place, again, there's a couple of delay in there. But as those efforts take place, the farmer confidence in the seed genetic potential is increased, and they're more willing to adopt those advanced varieties. So that longer term seed innovation in the hybrids, what I kind of showed in that seed cost thing going up, is an attempt to offset that by making the crop more resistant or more sustainable in light of the pressures. And then the final balancing loop there, that the hybrid seed allows that chemical use to be more effective. So hopefully that kind of makes sense and you were able to follow that. One of these things, if you're familiar with the systems archetypes that we've kind of drawn out, is a fix that backfires here. So as the weed pressure goes up, the herbicide use goes up, and that does offset it. But as we continue to use a particular herbicide, there's selection pressure for resistant weeds, and so a fraction of those end up being in the seed bank. The fraction of that goes up, and so over time, the weed population that's resistant goes up, and that simply reinforces the weed pressure. So that's kind of what we've come up with there. All that to say, the dynamic hypothesis, I'll skip reading this because now you've seen it in the CLD, but it's really a combination of the selection pressure and what that has done in the fraction of the weeds remaining resistant. And as those pressures continue to be felt in the long term, we've compensated for that by shifting chemistries, i.e. Different modes of action at different parts of the plant, different times of year, which gradually has been increasing the multiple herbicide resistance issue. But then in the longer term, we pushed on the seed technology to become more resistant and more resource efficient to try to overcome that. So that's kind of what our dynamic hypothesis is. I read the other groups just to give you a flavor, but if you understood the CLD, then it kind of gives you a sense of what our hypothesis is in that CLD. Moving then to the stock flow diagram, we tried to orient this about in the same area that the CLD was in. So kind of on the top left there, you see weed biomass. And as the weed is killed through the applications, that does in fact do its job, but inevitably there's a fraction that that does remain resistant in the seed bank, and the delay then into weed growth later on that reinforces the issue. As weed biomass is a problem, then that takes away from the crop harvest and quality, which feeds down into farm profit and the economic pressure dynamics that's being felt. And so as the pressure on the farmer feeds back into the application rates, that puts herbicide in the agroecosystem. And then that then comes back to offset the weed biomass there and the death or kill rate. So those are kind of our main loops there. You see the R loop for the biological weed biomass. You see the big from weed biomass through profitability to herbicide is the balancing loop. And that's what we've done to offset the weed problem. And then on the lower right, you see the economic reinforcing loop there because we can't avoid the cost of the application in the production system. So that's kind of a high level overview of our stock flow diagram. I know we're getting close to time, so I'll try to speed it up here. Here's kind of our preliminary simulation results. So the application rates are on in this case. So we're putting application of herbicide into the agroecosystem. So here's our stock of herbicide in the agroecosystem. Some of this is runoff. You see, or the decline is accounted for due to the runoff and due to the half-life of that in the environment as it does its job. What that does to the weed biomass, early on, the weed biomass is reduced over time, but again, because of the delay and the fraction that remain resistance, eventually that weed biomass does grow and actually become more of a problem than it was before because it's become resistant. And then finally, what does that do to the crop harvest loss? So this is the fraction in terms of, I think in this case, the units aren't listed there on the Vincennes figure, but this would be the bushel equivalent loss because of the weed problem. So initially, we might lose, say 60 bushels an acre. As we reduce the biomass, that helps offset it through, say, 50 months or the first few years there. And then as the weed biomass problem continues, you see that the harvest losses start to then go up again. So these are preliminary. This is kind of our first working version of the model that will eventually end up with presenting the final version at our capstone event in May in Fort Collins. What are some assessments that we've done? Again, as part of this fellowship process, trying to embed this, and how are the students doing in internalizing the concepts of the systems approach that we've been going through. So I don't have time to go through the questions that we have, but I designed a questionnaire around these core areas: mental models, dynamic reasoning, archetype structure, personal mastery, vision, and advocacy and inquiry, and then interventions, which is really the modeling component that we're just not really getting into. And you can see kind of the percent corrective responses in August when we completed the lectureship. And then after we've done the majority of our webinars in January, February 2020, you can see we have seen some improvement in mental models, archetype structures, personal mastery. The ones that either don't improve or go down a little bit, like dynamic reasoning, that's because we're really only just now in the heart of the modeling component, where those skills and that thinking is really going to express itself in dynamic reasoning and intervention. So my hypothesis and my hope would be that in June, when we do the final assessment after our capstone event, that those numbers would also grow like the other measures would have. Really quickly, because I know we're pushing some time here, we'll test our cohort models. Each of them is kind of designed, what we've designed the fellowship to do is they get their certificate with their final paper and presentation. And then, of course, with the pedagogical data that we've been doing over time as they go through the fellowship, we'll present that as well. And then what does that mean for people in our area, or my area specifically, that have some systems and want to develop these programs that don't have the capacity or the access to some other programs? So here's what we're trying to put together is a case study related to each one of our cohorts problems. We have some smaller scale developed resource management modeling labs in farming, ranching, and wildlife. So fleshing those out, those are pretty much done. It's just making them available. And then another one that is pretty much done is a role-playing exercise that I've developed over about 4 years now, that I've come to call the irrigation v. wildlife case, which may be worth a presentation in the future just on its own, because I think it's pretty unique. And then dissemination, where will this be? This summer we'll be in New Mexico for the North American Colleges and Teachers of Ag meeting, and we'll present the pedagogical data. And then certainly I'll be in Chicago for the 2020 System Dynamics Conference. And then accessibility, where can others access this as we close out the fellowship over the next year and make this available? We're working on a website where all this will be housed, the documents, the fellowship process, the case studies, and then the models and the learning lab stuff that I just referred to. Finally, the acknowledgements here, just to wrap up, to save at least a few minutes for some interaction for those that can stay on the call. My colleagues are Melissa Woolner, who was gracious enough to host our call today at University of Nebraska-Kearney. Aaron Cordes is in Ag Engineering at University of Minnesota. Stephen Chumley is in Ag Education. He's a colleague of mine here at A&M Kingsville. And Ryan Rhodes, who's in Animal Science, and he's at Colorado State. The funder for this has been the USDA Higher Education Challenge, and so none of this would be possible without the funding that they've given to put this fellowship together. And then other stakeholders are the King Ranch Institute for Ranch Management, who allowed us to partner with them to do our systems thinking lectureship back in August. It's a program that they're used to doing, and they allowed me, I co-instruct that lectureship as it is, but they allowed us to partner with them during that time to bring in our cohort with the cohorts that they bring in for their own program. And then for those that really know systems thinking, Michael Goodman is, one of the, I would say one of the godfathers of systems thinking. And he's been involved with our systems lectureship here in Kingsville, and has been just a wonderful advisor and teaching that over the 15 years that we've been working together here doing that. So with that, I appreciate your time and attention. We welcome, I know we're pushing the time, but I'll stay on as long as anybody else wants to stay on for questions, ideas, feedback. So I'll open it up. The floor is yours. I appreciate you all being here this morning.
That was a real nice presentation, I think.
Thank you, Richard.
I had a question. Some of these models, not just yours, but a lot of the ones that people do, let's say in agriculture or some other fields, they tend to be fairly general. And I'm wondering if you get feedback from some of the other people that wanted to be more specific and wanted to give you more specific, they want more specific advice coming out of that model, like they want to know which chemical they should use at what time and that sort of thing. Do you have a problem with that, where people are trying to push it to be very detailed?
We're going to find out really soon, because this is so, like I said, this is kind of the first version of our model. But but one of the students, this agronomy student, who's very in tune with these chemistries and things going on, because he's doing it for his thesis, and it's sort of a traditional field trial type of thing. And the first thing he asked was, well, what about, is it what chemical are we talking about, and that, all of that. And so yeah, this version certainly is, as a first version, very general. But I think if he brings to the table what I think he can bring, we can incorporate that specificity and the mode of action via whatever the chemical variety is, with the general structure that we've kind of put in place. And so I think something like, Vincem, a lot of us use Vincem. I think it's capable enough to handle that specificity while keeping the end result generalizable enough. So what I've kind of challenged our group to do is, even though this is a big problem all over the place, let's pick an area like where we are in South Texas, and we can build in, the growing season constraints and the precipitation statistics, and put those varieties in. And we know what the crop yields are, because we've had 100 years of crop data down here. And so I think it won't be as specific as the agronomists like, but I think we'll be able to pull in some of that specificity without losing the overall story.
Yeah. Okay. Thanks.
Yep.
Hey Ben, this is Saeed. A very nice presentation. Thank you very much. That's a wonderful effort. So I have a couple of questions. Are you the only system dynamicist in this group of cohorts, or you have also other system dynamicists involved, for example, in Colorado or other places?
Yeah, so probably by our definition, I would be the only system dynamicist. But a little bit of background about my co-PIs and why they're so involved in this for so long, and so a little bit of history. So Dr. Melissa Woolner at Nebraska Kearney, she prior to being at Nebraska, she was at South Dakota State, where I did my Ph.D. and was on my PhD committee. And going back, I want to say to when we first did our systems lectureship in South Dakota, which was 2011, she was there. So she's been, you know, kind of involved in various ways supporting me. She was also a PhD mentor to Hector. You know, we all know Hector. So she's been through this process a number of times in other ways. Erin Cordes at Minnesota, prior to being there, she also had a South Dakota State connection that me and Hector and Dr. Woolner have. And so I don't remember I think 2014, she went through the lectureship that we did at South Dakota. So again, over a number of years, she's had some exposure to going through the process. And then Ryan Rhodes, who is at Colorado State, prior to being there, he was here at A&M Kingsville and was a part of the King Ranch Institute for Ranch Management. And the King Ranch program is built around a systems approach. They don't do systems modeling, but it's more the iceberg, thinking about mental models and root causes and archetypes and that kind of thing. And so they've had their lectureship here in Kingsville that Mike Goodman has been a part of for 15 years. And so he, as a faculty member, was a part of that lectureship. So we've all kind of been through the process. So we're familiar with it, but in terms of hardcore modeling, Saeed, and the modeling webinar and, you know, all the support for the models, that kind of gets kicked back to me as the system dynamicist. But we've all had some exposure somewhere along the way that we've been a part of.
Yeah, thank you. So how much do you involve students in the process of modeling? My understanding is that the students that are in the cohorts do not have, you know, so much of the background of system dynamics modeling. So, but the model that you develop seems to be very kind of like very high-end model. I mean, in terms of techniques, I see that it is not the student work. So do you take the you know, the majority of the lead in the modeling, or do you also involve the students in the actual modeling, or the students remain more at the systems thinking level rather than doing the actual modeling? So can you comment on that?
Yeah, that's a great observation about the model schematic that you saw and kind of what you know about our students so far. So yes, certainly I provide a lot of support, and the under the hood stuff of Vensim, I have to walk them through what that looks like to do it. But in terms of building that schematic, let me tell you what they did. So in the fall, we went through the process, and they had developed a high-level CLD that I showed you, and we're working on that dynamic hypothesis and collecting all the data that they could find, so on and so forth. And then since about Christmas, and we've kind of moved into this modeling phase, what I told them was like, okay, you've got to refine your dynamic hypothesis. That was them. I said, you've got to go talk to an expert in herbicide, go talk to an agronomist who knows about this, and get what they say about what you found about the issue. They did that. Then I said, with this dynamic hypothesis, what I want you to do is make a list of variables that are going to be endogenous, that have to be core to the feedback of the model. Which one of those are stocks, which ones are flows, which ones are information links, and then what things are probably going to be important but exogenous kind of drivers of the model. They did all of that. So the schematic that you saw was them. They didn't, you know, they needed help to put the schematic together, Saeed, but those variables being identified in that way was them doing the process. Now, as you say correctly, the under the hood mechanics to get things working, yeah, that's me sitting down with them one-on-one to make those revisions. But the organization really has been a product of what what they identified. So I would commend them for.
That's great, actually. So I hope that you are documenting all these processes and give us the reports in the dissemination phase, because that is very useful, for teachers. And finally, my final comment is about the model. And I mean, you can disregard this if it sounds irrelevant, but the model looks like very much similar to a drug addiction problem. So just take a look at those literature. Maybe you could find some similarities, and it may help to kind of like generalize your model even to a higher level. So because the pesticide resistance, those economic factors, and then you have also companies who are developing even more kind of effective drugs. So so that sounds like kind of like drug addiction problem at the health policy, public health issue.
Yeah, I really appreciate that connection, Syed. I had not thought about looking at that. So that's a great connection for us. And we will certainly look into that for sure.
Okay, good luck. Thank you so much, Ben.
I have a question here from Alberto. Due to the background noise, didn't want to chime in. But he said, I'd like to ask, which difficulties did you find, i.e. limits of the methods or delays in student learning? I think probably the biggest difficulty that we've encountered is probably one that naively we didn't think would be too big of an issue, but as humans and organizations go, these issues always come up. The real difficulty has been keeping the teams cohesive and friendly to each other. Because, and as all of us work in systems, it's best done in teams, and that's why we've developed this cohort approach. And so the real problem, the real challenge has been there's certain personalities that just don't get along, and we've got to come up with a way to smooth that, those egos over and headbutting, to sort of iron that out as best we can. So that's really been the thing. And I think for them that I hope that's helpful for them in the long run, because, as a master student, we're typically just, kind of focused in, honed in on our project. And we force them in the cohorts to work as a team on these projects. So, when you get in your career, there's nothing we do, certainly for a lot of us in academia, that we do alone. We're always on a committee this or a committee that, and so it's just part of life that we have to deal with. So Alberto, that's kind of been the main difficulty, is those personalities. Great. Well, again, I appreciate everyone's time and attention. I don't hear or see any other comments, but I'm not sure if everyone caught the plug at the start as we got started, because some folks came in maybe a minute or two after we started. But I'm glad Alberto and Richard and Yinning and Saeed are here to kind of hear this. And Christine, I know you've been on a few as well, and you heard before. But with a couple of years momentum now in the Ag SIG, I'm not sure what the process will look like, but I'm open to ideas. I'm open to criticism, feedback, whatever we want to come up with. But I would kind of like to maybe stretch ourselves, for those that are here quite often, to think about what we may do over the coming months up to the Bergen conference to prepare for the Chicago conference, because we've had a couple of years momentum, and I know the society is paying attention, because they reached out to Hector to ask for a SIG update to go in the newsletter, and so he'll make a report to go in the newsletter. And so we normally get a SIG time at the meeting to interact and to do something, but I think it might be both fruitful for us as a group, since we have had some momentum over the past couple of years, and maybe make a larger splash at the meeting so that people are paying attention that we're a SIG, we're alive, it's vibrant enough to continue this momentum for a few years. If we have some other product at the conference to show. And I don't know if that's just a poster together, if it's I don't know what it is, but I'm open to ideas, interpretations, and I'm willing to be stretched, if you're willing to be stretched, to try to put something together for the Chicago meeting. So I think would be the right time to plug that as we look forward to the next year, this coming year, to see what we may do. So with that, hearing no other questions or comments, we're about over time, and Hector sends his regards. Again, he's kind of between jobs and things right now, so he couldn't be here today. But again, appreciate y'all's time and attention, and we'll be pinging you guys for emails for upcoming meetings if there's no other comments. So
Yeah, well, thanks a lot. It was a nice presentation.
thanks, Richard.
Thank you, Ben.
Yeah,
Take
thanks,
care.
Clay. We'll see you guys.
See you. Bye.
Thank you. Oh, I have random comments.
Oh, okay, great.
Question. So I saw on one of your slides when you had a video, and at that point where you stopped in the video, it said Genesis of System Dynamics. Is that a YouTube video, and is it available to the public? Because I've been somewhat marketing the SIG, like, was it Busra's presentation last month? I marketed that through the WPI System Dynamics Twitter, and I've been commenting on like various social media trying to get people to join the SIG.
Yeah, so that image from that webinar was just one slide of my modeling webinar, where I just give the students a little bit of background on where it came from. So the names I have up there is the father of general systems theory, Ludwig von Bertalanffy. And then below that, I have Jay Forster, Peter Singay, John Sturman, and Mike Goodman. And all I do is just put a plug on, hey, these are some big names in the field. You need to know who Forster is. You need to know who Singay and Goodman and Sturman are. Here are the major works: business dynamics, study notes in system dynamics, the fifth discipline, so on and so forth. So it's really just one slide out of my modeling slides. And we have it recorded. It's not on YouTube or anything at this time, but once we get all this stuff polished up and on the website, all that will be there. So eventually we'll have a link, but we don't have a link ready for it yet. So.
Okay. That was just my random question.
Yeah, I wish we had it ready, but we just got to do some more polishing and things just to get it ready to go. So.
I understand.
So.
And my internet is lagging, so sometimes I don't hear you until certain points, and then all the audio comes at the same time. So if I'm interrupting you, I'm sorry, because I am not so sure if you stop talking. But right now it seems good because your voice and your head and mouth is moving at the right times. Okay. So also there was an app I saw a couple of months ago, and then I forgot about it, then found it again earlier this week, and it just happened to be the same week that you're presenting. There's some group, I believe in India, or no, I forgot. Please don't hate me if I'm wrong about what country people are from. I didn't get to look much at this app yet, but I thought it might be relevant. Oh, it's definitely relevant to your group.
Yeah, I just saw your comment there, and open the link. Danny, in a time of change.
Mm-hmm.
Interesting.
And so I don't know if Melissa is always available for your meetings, but if I'm available, I can also help with the Zoom link or whatever you need.
Okay, yeah.
So I
let
am
me,
part of the
let me
SIG.
make note of that. Is it an, do you have an institutional Zoom? Is that, okay, perfect, yeah.
Yes,
So-
and I can make a scheduled meeting, and I think we've been meeting at this time for the past couple of months, so I
Right.
can just make one and everybody can use it, but only I have access to the recording.
Right,
Yes.
so, yeah, that's great. You know, Hector has been our host for a couple of years now, and that seems to have been working. But he's in between. He's taking this new job, and so in between, and we were like, oh, what do we do with the SIG, because he wasn't going to have his. So, anyways, it kind of all worked out, but I'll let him know about that for sure. That you have your own institutional Zoom that can send out that schedule. That'd be great.
Okay, that's
So,
it.
I'm not sure who else is on. See, Alberto, you're still there.
Yes, I'm still here, but there is a lot of noise. Don't know if you can.
Yeah, we can hear you. With only 2 or 3 of us, it's probably not too bad if you want to chime in.
Yeah, yes, and I have not contact in these days with Hector, but uh, we can send some more information to Christine on the material we have, and also include her in the group.
Right.
There was a more specific question, right?
No, I was just saying, with only like 2 or 3 of us left on the call, if you wanted to chime in, that's fine. I didn't have a question, but
Ah, okay. Yes, okay.
so.
Thanks, Ben.
Yeah,
It was a great meeting.
Hearing no other questions or comments, I guess I'll call the meeting closed. And Christine, Alberto, and everybody else, thanks again for participating. See ya.
See you. Thanks.